You would never drop a new engineer into a Rails app and say, just figure it out. I spent a lot of my career being responsible for getting engineers productive inside of real production code bases, and the pattern is pretty consistent. The faster they understand the setup, the architecture, the product context, the test, and the decisions behind the code, the faster they can make good changes. If we haven't met yet, I'm Damien, and I've been a software engineer for over 15 years. Today, I want to show you how I set up a repo so that a coding agent has the context it needs before it starts changing code. Because the usual workflow is almost the opposite. We open the repo, paste in a task, and expect the agent to infer the setup commands, the architecture, and the product context, and the testing expectations from the code alone. So I'm going to walk you through how I set up agent onboarding inside of a real repo. Let's take a look. This is CreatorSignal. It's a Ruby on Rails app that I've been building for a little while now. You might have seen me working on it in some of my live streams in the past. And today I'm going to walk you through how I set up onboarding for the agent inside of this repo. The first thing we're going to look at is the AGENTS.md file. This is the root of everything. And so AGENTS.md is going to be used by various coding agents, including Codex and others. Now, I've also symlinked this file to the Claude MD, so that way they're referencing the same file. And in here, we give the agent a description of the Rails app itself. So giving it some context on the application and how to orient itself inside of our application. First piece is we talk about the project. So we talk about how CreatorSignal is an AI content strategist for YouTube creators. Users submit the idea, the app researches it across YouTube, Reddit, X, and Hacker News, and then returns a scored go, refine, kill verdict with evidence and recommendations. So we give it this kind of like baseline understanding of what the application is so it knows what it's working inside of. Then we also mentioned that CreatorSignal is a Rails 8.1 app built with the Thoughtbot Suspenders gem, PostgreSQL with PG Vector, SolidQ, and Hotwire. The next kind of important part of this is we give it some instructions on how to build and run the app. So in this case, we walk through the various commands that are there. So bin setup for installing dependencies and preparing the app, bin setup reset, so it can reset the local state and reseed, bin dev, which is going to start up dev server and local processes, and then bin jobs, which starts SolidQ worker on its own when it's not running inside of Puma. So now the agent knows how to kind of get things started whenever it needs to. Now onto the session startup. This is one of the more important pieces of the AGENT.md setup that I have going. In here, I basically explain to the agent what it should do whenever we start a new session so that it can kind of catch itself up on what we've been working on and where it is. So it's broken up into about 7 steps here. And the first is going to ask it to run the PWD. So here we're just confirming that you are in the right repo so it knows where it is inside of the system. The next, we do a git status with the short and branch flags. So this just kind of gives it information on what branch it's on and the current status of the local changes. So whether the work tree might be dirty or not. Then we have it run git log with 1 line and get basically the last 10 logs. So this kind of gives it an opportunity to catch itself up on what kind of work has been happening in the past before it got here. And we go ahead and run git fetch origin because sometimes I run into issues where maybe various changes have been pushed up to the remote and Codex doesn't automatically remember to maybe pull down those changes. So here it's going to actually run fetch origin. It doesn't actually pull the changes down, but it gives itself some context to know that what is up against origin main. You might, if you want, in your setup, you might want to say git fetch origin and then have it maybe run git rebase origin main or pull or something like that. Then we have it read a progress.md. So you may or may not have this kind of file, but sometimes a progress.md is used for kind of keeping track of progress inside of the application. This can be useful also for like long running sessions. So maybe you're working on say one larger epic and you want to be able to keep track of the progress of that epic inside of this progress.md file. So that way, if you need to say clear context window or anything like that, it can go ahead and kind of refresh from the progress.md to catch itself up and bring itself back up to speed. The next is to read the relevant docs. So there's a docs folder, which has different documentation, and then there's a map further below that we'll kind of get to. And then we run a targeted smoke check. So making sure that the repo is in a clean state and that things are working and operational. So if the repo is already failing for some reason, say whether that's test or linting errors or formatting or anything like that, we're going to have the agent report those things back to us so we know, so that we can decide what to do about it, so that we're not just working inside of, say, a broken state from the start. So then we go into our test commands. Here we outline the various ways to run the test suite. So for instance, we have bin rail spec. That's how you run the full test suite. We have bundle exact RSpec with a path. That's how you run a single individual test. Then we have how to run it by a single individual test on a specific case, how we run linting, how we can do a security scan, how to check for vulnerabilities in our dependencies, and then bin CI, which is the full CI, lint, and security tests. So kind of how you can run everything. On line 40, we give it some instructions on what it should do while it's iterating. So typically, when it's running through its feature, it should use targeted specs while it's iterating. So basically running the individual tests for maybe the files that are impacted by its changes or the surrounding tests and things like that. But then later, it should run the relevant broader spec before finishing. The architecture docs. So we have a section in the docs around architecture, which goes into a code map, domain model, service boundaries, and architectural patterns. We highlight some key facts, such as Rails models represent users, ideas, validations. The research orchestration lives in app services. There's some background validation work that runs through SolidQ, and the UI behavior uses Hotwire, and there's multiple databases set up. The docs architecture will go into more deeper contents about this, so it can kind of catch itself up from there. Then we reach the documentation map. Here's where we kind of outline where the various pieces of documentation might live so that it knows where to find things. So we also instruct it to read the relevant doc before starting work in an area. So some examples of those are there's the documentation index, which is in docs readme. There are stack, patterns, and domain model. That's in docs architecture.md. We have testing patterns and stack, and that's in docs testing. Credentials, envars, API keys, that's in docs configuration, so how we configure the application. And the list kind of goes on from here. So mapping the directions or where to find any documentation that the agent might want to have. So for things like this, like an agent might find it on its own, but it might have to go searching more and more. So it might use your tokens to use those steps. Here we give it that straight map so it knows exactly where to look instead of having it to spend tokens to kind of find where all of these documentations live. So it's both a guide for helping the agent be successful in the code base, but also a tool to help you kind of save some tokens. Next, we go into our definition of done. This is important to guide the agent so it understands when it should consider its work complete. This prevents those scenarios where the agent says, I'm done, but it actually hasn't finished all the work. So now let's dive into the actual docs themselves and what the agent would see. So this is the docs readme file, which kind of gives just an index of what exists in this folder. We've stored some product specs, which explain how the product is meant to function from a product design perspective, including the core index, an API and CLIs piece, and some archive ideas. We provide some notes for references. So we have some Stripe webhooks infrastructure that's set up. And so there's an entire section dedicated to that. Then we have design documents. So core beliefs around how we design the application. So engineering principles and invariants for the code base. Design docs is for design explorations and non-ADR engineering notes. ADRs are architecture decision records. We use those to capture significant decisions and their rationale behind them. So this allows the agent to kind of understand the changes that have been made over time and why we made those decisions. That is useful for when sometimes you go back and forth with an agent, build something out, come back later, and the agent kind of decides, well, I'm going to do something differently. Here, it can kind of look through the ADRs and understand how we got to those points and why the rationale was there, and kind of use that to guide it as it moves forward through new decisions. We have the first, which is the agent-ready documentation structure. The second one is the Rails Hotwire monolith baseline. Then we have decision-oriented validation reports, pluggable research agent tools, async validation lifecycle, and idempotent webhook event storage. Now let's take a look at the Architecture.md. Here we start off with the stack. So understanding the core technology that powers the application and the system. So we talk about Rails, it's on Rails 8.1. The database is using PostgreSQL with PG Vector. Background jobs use SolidQ. Front end is Hotwire and Turbo and Stimulus. For JavaScript, we have an import map, so no Node.js build step. Our assets are handled by PropShaft, and some details about the Docker DB image. Domain model covers some of the core concepts inside of the system. CreatorSignal validates YouTube video ideas, and the core flow is a user submits a video idea, a validation job is enqueued, the research agent runs tools against YouTube, Reddit, X, and Hacker News, results are synthesized into a scored go, refine, kill verdict, and the report is displayed with evidence and recommendations. Key models. we talk about the key models that exist inside the application. So we have user. So that includes the authentication and subscription plan. Idea is a video idea submitted for validation. Validation is one run of the research agent against an idea. Stripe webhook event, idempotent store for all incoming Stripe events. And a channel is a user's YouTube channel injected into the research context. Then we outline some of the core services that we have. So we note that the research agent is the orchestrates the research loop. We have tools, so for base, registry, YouTube search, comments, YouTube channel stats, Exa search, and X search. Then we go into the project structure, so app components for view components, controllers, which is the typical MVC controllers folder, jobs for active job, mailers, models, services, views, etc. Then we outline the spec directory. So the spec has factories, models, services, and system. And we outline that factories use FactoryBot and that the system specs are Capybara system test. Then we go into some key patterns in the application. So we have strict loading. N+1 queries are caught automatically. Use strict loading false only when it's intentional and documented. We use strong migrations. So strong migrations are used for validating for safety, and that it should only use safety assured only after verifying the migration is safe. So this is helpful for making sure that an agent is making migrations responsibly as it's building them out. Now let's take a look at some of our product specs. We won't go too deeply into the first one, but you can see here that this outlines basically the core concept of what CreatorSignal is as a whole. We talk about the feature index. So there's the idea submission flow, the research agent, the validation report, the gated shared reports. And we've also noted what has been shipped and what hasn't been. So right now, all of those features in the feature index have been shipped. If we dive into the CreatorSignal API and CLI, we can see that this was a future feature that I started creating afterwards, after the core kind of MVP of the project was created. And so here we were trying to create a API for agents to use using an agent skill or an MCP to actually interface with CreatorSignal. And so this was a product spec that we built out together with an agent and then broke up into actual implementation. So we have the overview. It's currently a web-only product, and we want to move it to a CLI-driven batch validation. PRD defines a JSON API that enables AI agents to submit ideas and retrieve results programmatically. CLI tools to validate ideas from the terminal without opening the browser, and a webhook for consumers to react to validation completions in real time. We established some goals, some non-goals, and then some overview of what we're trying to build. So including a data model, what the authentication flow is going to look like, the key management, rate limiting, and API endpoints. So here we kind of defined everything we were trying to work towards when building out this application and building out this feature set. So a lot of effort was put into kind of planning out what the feature was going to look like before we actually dove into passing it off to the agent to implement. So now let's look into the decisions folder, which holds our ADRs. This is an example of one such ADR. So number 6 was idempotent webhook event storage. So here we end up capturing the pattern we used for handling Stripe webhooks. So CreatorSignal receives Stripe webhooks for billing state and sends validation webhooks for external consumers. Webhooks are inherently retry prone, so providers can send duplicates, jobs can fail midway, and operators need to inspect and replay events when production behavior is unclear. And so what we did was we made a decision to store all the incoming webhook events before processing. So the Stripe controller verifies and constructs the event, then creates or finds a Stripe webhook event by Stripe event ID. And the whole payload is then stored into the database so that if we need to replay it, retry it, or anything like that, we can. It also gives us that ability to kind of replay or rebuild the structure if that ever happens. This ADR captures all of the decisions that we made when we were building out this specific feature and how we got there. And then we actually also link out to different sources, like say the docs references Stripe webhooks, what models were involved, and things like that. So if we ever need to understand like how we got to a position, we can go through these historical ADRs and understand that. So now let's go ahead and actually run through a fix in the system so that we can see all of this come into play. So what we're going to do is take a look at a feature that was implemented in a little bit incorrectly. So we have a feature for the API where the PRD specifically calls out that every successful API key authentication should update the last used at, but only once per minute to avoid overwrite, but only once per minute to avoid write amplification. And that's not happening right now. So I'm going to go ahead and submit that prompt to Codex, and let's take a look at what it does as it kind of gets itself up to speed and works on this feature. So we can see here, the first thing it says, I'm going to follow the repo startup checklist first, then read the API CLI product spec and the current API key auth path before changing anything. After that, I'll add the failing spec for the debounce behavior and make the smallest code change that satisfies it. So we can see here already it's following our TDD practices that are defined in the agents.md. So it ran PWD, understanding where it is in the system. It got the git status using short branch flags. It did git log to understand what's been working on, and it's doing a search for all of the things related to the API key, debounce, and things like that. Now it's saying the startup context. So the repo is ahead of main by 4 commits, but there's no dirty changes near locally. And it's refreshing the remotes now and reading the API spec to understand what's there before it actually goes and touches anything. Now it says it's confirming that the source of truth PRD explicitly calls that the debounce should be once per minute and that it doesn't currently do that. It actually touches it every single time. So now it's going to check the model and API controller specs to pin the right test layer. So it's understanding where the right place to put this test is. And it mentions that the mismatch is in the model and that the authenticate method currently owns both the verification and the last use at updates. And it's running the targeted model spec as the baseline smoke check, which is one of the things that we outlined as the session startup. So it ran into a couple issues with Ruby using the system Ruby and not the one by Mies. So it's fixed that and ran the smoke test and everything's good. So now that the baseline is clean, it's going to go ahead and actually add the test to recreate this issue and an expected failure. So it ran that, but it caught an issue in the new spec before running it. So re-authenticating just to read the timestamp with itself exercise behavior, tightening the spec to read via reload, so only writes are intentional auth calls. So now that it has the debounce spec in place, it's now going to run it. And it has the first red test exposed a test helper gap, so it's fixing that. So it refactored the code, implemented a fix, and so now it says the model now exposes last touched at, bang, and only writes when last used at is absent or at least 1 minute old. Now it's going to rerun the focus spec. Then it says it's going to lint on the touched files, and if that stays green. Now, once it's done that, the focus model spec is green with a new debounce coverage. I'm running the API auth request spec plus repo-local next. So now it's going one layer out to make sure that the adjacent tests or more exposed tests are running and passing as well. Finally, it says that both the API auth request spec and repo-local on the touched files pass. So now it's going to do a final diff and status review now. Given the narrow model change, I'll decide whether a broader suite run is worth the time after checking the footprint. So it's kind of determined based off the changes, the diff is limited to the API key model and its spec. I'm running the full repo-local command from the AGENTS.md, but it's going to keep the test run targeted because the affected behavior is isolated to the API key authentication. So it's made a judgment call on its own that the full test suite likely doesn't need to be run, but instead anything related to the API should. So it's going to run those tests on its own instead. And finally, it gives us a summarization of what was implemented and what was changed along the way. So we can see here how that whole system came into play. It ran through lots of the pieces of the agent-ready documents, including the AGENTS.md, the product spec, some of the architecture MD, and other files to help it understand the code base and the procedures that it should follow whenever it was implementing this feature. I like this example because the fix was small. We didn't need a dramatic feature build to see the pattern. Codex had a better shot at making the right change because the repo gave it the same things I would give a new engineer. Some setup notes, architecture context, product context, testing expectations, and decisions behind the code. This is what I mean by making a repo agent ready. It's not about writing a giant prompt. It's about moving the context out of your head and into the code base where the agent can actually use it. So before you ask an agent to make any serious changes, ask yourself, if this were a new engineer joining the project today, what would I need to hand them first? The answer is probably the same context your coding agent needs. If you want help getting your repo set up like this, I've put together a free agent skill that you can use. I'll leave a link in the description. I'll see you in the next one.